Mhm. So we were doing RC circuit analysis. RC circuit analysis is being done uh, in two contexts. One is AC, another is DC. What we were doing was DC circuit analysis. Last class we discussed about the charging of a capacitor, and we have seen some expressions that we will just recall here. So in charging of a capacitor, that means, let's say this is the resistance R, this is the capacitance C, and it is connected to one battery with EMF E. This is the switch. Now when switch is on, just after switch is on, that is at t is equal to 0 plus, we have seen what are the values of current. So current will be maximum, that is E by R, that will be maximum current. And the voltage, if we look into this, voltage will be 0 at t is equal to infinity, that is in steady state. In steady state, we have seen that current reduced to 0 because the capacitor containing branch acts as open circuit. So current was 0 and the voltage across the capacitor will be maximum, which is equal to EMF of the cell. In between the transient state, we have seen different formulas, like charge at any instant t is given by maximum charge 1 minus E minus t by time constant tau, where tau is equal to R into C. Similarly, we have seen that potential difference across the capacitor at any instant time t, that is in transient state, it is given by V naught 1 minus E minus t by tau. In these two physical quantities, they grow exponentially during charging of a capacitor. But the current in the circuit, it will decrease exponentially during charging of a capacitor, which is given by IT is equal to I naught E minus T by tau. And we have seen the graph also related to this. Also, what do we mean by one time constant? So if we look into the graph of different physical quantities during charging of a capacitor, we have seen that charge, if we plot charge along y-axis and time along x-axis, so we have seen it will grow like this. It will start from 0, charge will start from 0, it will go and tends to meet Q naught at t is equal to infinity, which is the maximum charge possible. So, yes. Now here we have seen that what is time constant. So when you put t is equal to tau, you will see that Q is equal to Q naught 1 minus E minus tau by tau. That will give you Q naught 1 minus 1 by E. That gives you 0.63 of maximum charge. That means we will say that time constant is that time during which charge in the capacitor increases up to 63% of the maximum charge. Similarly, if we look into the voltage graph during charging of a capacitor, it will also bear the same resemblance. This graph will be also same because it is increasing. And the charge, since it decreases exponentially, it will be like this. It will start with I naught and it will go like this. In terms of current, we can define time constant as that time during which current reduces to 37% of maximum current. That we can define through this, we can define the time constant. So here also time constant will be defined in terms of voltage. Also we can define in the same way as that of the charge. So this is all about the charging of a capacitor. Now we will discuss about the discharging of a capacitor. Okay, thank you.